All right, today is Unit 1, Day 5, and we're going to do systems that have three variables now. So if you look at this guy, we have an x, a y, and now a z involved. In order to solve these, though, we need to have three equations. If you have three variables and just two equations, there's no way to solve it. So however many variables you have, you need that many equations also to solve these guys. And today we're going to focus on just using the substitution method, which is actually the exact same method as what we use with systems of two equations, but it's going to be a little bit more work. So we're basically doing one thing the whole day, but it is kind of a difficult thing. So first, let's just look at what a solution could look like. If you look here, there's three numbers. We had ordered pairs before. We had an x and a y. Well, now this is considered an ordered triple, as an x, a y, and a z. So they're asking, is 3, 0, negative 1 a solution to this system below here? The only way to find that out is to plug in 3 for x, 0 for y, negative 1 for z into all three of these to see if it makes them true. Does the first one equal 4, the second one equal 8, and the last one equal 14? So I plugged into the first one here. I plugged in 3, 0, and negative 1. And is that true? Is 3 plus 0 plus negative 1, which is going to be a plus, does that equal 4? And that is true. That's good, but that's not good enough to say it's a solution to this system. It's a solution to the first equation, but let's keep going. So plug in 3, 0, and negative 1 into the x, y, and z. I got 9 minus 0 plus negative 1. So 9 minus 1 is 8. So that's good. But again, we need all three of them. And for the last one, notice there's no y, so there's nowhere to plug the 0, but I plug 3 in for x. I plug negative 1 in for z, and I've got 15 plus negative 1, does that equal 14? And it does. So since it makes all three equations true, then yes, that is a solution to this system. Okay, now we got a different system over here we want to check. Same idea, we're going to plug it into all three of them. Okay, so I plugged in 3, 0, and negative 1 into all three of them, and let's start checking. So 14 times 3, that's 42. 3 times 0 is 0, so minus 0. And then 5 times negative 1 is minus 5, so 42. Again, this is minus 0 minus 5, that is 37, so that works. Then I've got 9. Again, that's 0, so that's just gone. And then this would be a plus 6. Now, is 9 plus 6 equal 10? No. So if I'm sure that I did that right, I don't even need to check the last one. It's a no, because it did not make all three of them true. Okay? So that's if you know the solution. Now, let's move on to what to do if you don't know the solution and you're trying to find it. Now, this first one, these are basically the easiest kinds of these problems because we have one equation with one variable, one equation with two variables, and one with three. So this is perfect for substitution. And what we're going to do is we always want to look for, if you have one variable, look for an equation that has two variables. If you know what one of them is, look for one that has two variables and plug it in. And if you have two variables that you know, like you know the values of those two, look for one with three. So right now I've got z equals 5. I know z equals 5. That's part of my answer. When I go to write my answer, it's going to be something, comma, comma, 5. I'm sorry, something, comma, 5. So I know one variable. I want to look for an equation that has two variables, and it needs to have that variable z in it. That's this guy. So I'm going to do y plus 3 times 5, set that equal to 14. So just plug in a 5 for z. I get y plus 15 equals 14, subtract 15. Y is negative 1. So now I have two variables. I know what y is, I know what z is. Now I can use one of the equations with three variables. Okay, so plug these both in for the y and the z, leaving one variable to solve for. It's always our goal is to have one variable to solve for then. So I've got 2x plus 3 times negative 1 minus 5. So I got 2x, this would be minus 3, and that's minus 5 equals 8. So that's 2x minus 8 equals 8. Add 8 to both sides. So x is 8. Now if we go back through and we plug all of these in, it'll make all of these true. That one's not so hard to see, but at any time if you're taking a test or a quiz, you can always double check by plugging all three into all three of these. You're probably not going to want to do that or have the time to do that on your homework. I do advise to do it on your test or quizzes, just make sure you're right. Okay, next one then. notice we had one equation where we already knew one of the variables. We're going to take that out now. So now we have two equations that have all three unknowns, and we have one equation with two unknowns. So and if we're using the substitution method here. So substitution was if you don't already have a variable by itself, you need to get one by itself. So I'm going to look down here. This one, I'm going to get that z by itself. So it'd be z equals 7 minus 5x. I'm going to plug in for both of these z's. I'm going to plug in z equals 7 minus 5x. Let me label these equations too. That might make it easier to follow too. So let's call them 1, 2, and 3. So I'm going to take equation 1. I'm going to write it down, but I left a gap where z was because I want to plug this in into z's place. Okay, and then I'm going to do the same thing with equation 2. I'm going to write it down and leave a gap for z. Okay, so here's a gap where z was. I'm going to plug 7 minus 5x in its place. And now I need to simplify both of these. And if you look at both these equations, they now both have just two variables. This has x's and y's. This has x's and y's. So I basically eliminated, I got rid of one of the variables by substituting. So let's simplify these two. So when I subtract, remember you're subtracting both of these. So it might be easier to think of this as add the opposites. So if you switch that to plus, and then switch both these signs in here, it makes it a little bit easier. We make less mistakes when we're adding, but when we're subtracting, we make more mistakes. So over here, that is plus already, so we can just put plus 7 minus 5x equals 4. Okay, combine like terms, so 6x plus y, and I'm actually going to bring that 7 to the other side. So I combine the x's, rewrote the y, now I'm going to bring the 7 over and say it equals 7. Here, combine the x's, so negative 2x minus y. Bring that 7 over as a minus 7. I'm going to subtract it over, so that equals negative 3. And now I have two equations with two unknowns. This is what you've been doing for the last 3 or 4 days. You have an x and a y and an x and a y. So let's look at these two. And since we know how to eliminate and the y's are the same, so this is a plus y and that's a minus y, they're the same but opposite signs, I can actually put these on top of each other. Okay, and I'm going to add straight down. So I used, kind of reviewing here, I used this equation with two variables. I plugged it into both of them. So I plugged it into that z and that z. The result was two equations, two unknowns. I'm going to put them together and solve for one of these two. So I got 4x, the y's go away, and that equals 7. I'm sorry, equals 4. So I divide by 4, x equals 1. Okay, so perfect. And my solution, when I'm writing my solution down here, I've got a 1 for x. Okay, now that I have one of the variables, I'm looking for an equation with two variables, one of them being x, so I can plug it in. I've got one here, I've got one here, and I got one here. It doesn't matter, whichever one you want. Now if I plug it into this one, I'm going to be solving for z. If I plug it into one of these x's, y is left, I'm going to be solving for y. So I can really just use that to find my last two answers. So let's use this guy here. So I got z equals 7 minus 5 times 1. So 7 minus 5 is 2. If I want to find y, pick one of these. I think this one's going to be easier to solve for because I got a positive y by itself. I don't like negative y's. You could use this one, it doesn't matter. But I got 6 times 1 plus y equals 7. So if I subtract 6, I got y equals 1. So this would be my ordered triple, my x, my y, and my z. Okay, on the back side now, 3 equations, they all three have 3 unknowns. This is like the most difficult we can make it for you, okay? And the approach on this, let me just number these guys, 1, 2, 3, is I'm going to combine, I want to pick a variable that I can eliminate twice, okay, that I can get rid of twice here. So I think, or it's a bit better way of saying that too, is what variable could you easily solve by itself? Okay, so I can get this y by itself pretty easy. It's a positive y, bring everything to the other side. So let's go to that route. Let's say for equation 1, I'm going to get y by itself. I've got 3 by itself here. When I bring the 2x over, it's minus 2x. When I bring the z over the other side, it's a plus z. Okay, so I've got one of the equations, I solve for a variable. Now I'm going to plug it into the other two. Anywhere you see a y, plug it in. So this y and this y, I'm going to plug these guys in. So I'm going to rewrite them with gaps for the y's. Okay, so equation 2, I left a gap for y. Equation 3, I left a gap for y. And what I'm going to fill in that spot is this guy. So 3 minus 2x plus 7, 3 minus 2x plus 7. Okay, do some distributing here. So 3x, it'd be a minus 3x. I'm sorry, a minus 3, a plus 2x, because it's negative 2x, and then a negative 7 plus 3z equals 3. And notice in this equation how many different variables? I have x's and z's, and that's it. So just two variables. I got rid of one of the variables. In this guy, I got negative x. I'm going to distribute the negative 3, so it'll be minus 9 plus 6x minus 21 plus 2z equals 3. So it's looking kind of ugly, but most of the work is in this first step. Okay, so combine like terms. I got 5x. My z's would be 3z. And here I've got minus 3 minus 7. That'd be minus 10. So I got a negative 10. I'm going to bring it over as a plus 10. So this would equal 13. On the other side, x's would be 5x plus 2z. And this would be a negative 30. Bring it over as a plus 30. So this would equal 33. Okay. Two equations with two unknowns. That's what we've been doing for the last several days. I notice my x's, I could easily eliminate those. I'm going to make one of these all negative. So I'm going to do 5x plus 3z equals 13. Over here I'll do negative 5x. I'm going to make all these negative. Minus 2z equals negative 33. So that would be a z equals negative 20. I'm just now seeing a really dumb mistake I made. This was a z, and I put 7 in here. So these should be z's, which means that this is a negative z. This one would be a negative 3z. Oh my goodness, take your time, folks. Don't go too fast when you're doing this. So this would be, let's see. Okay, so over here, this would actually be a 2z, because you have negative z plus 3z is 2z. You have a minus 3 that you got to bring it over to the plus 3, so that'd be 6. Over here, this would be negative 3. Negative 3z plus 2z would be a negative z. And then the minus 9 would be plus 9 over here, so this would be 12. I'm sorry, that stinks. Let me start over here. So I'd have 5x plus 2z equals 6. And then I would have negative 5x, and I'm switching these signs, plus z equals negative 12. So I'd have 3z would equal negative 6. So divided by 3, it'd be negative 2. So I'd like to say I did that on purpose to show you how not to make mistakes, but that would be a lie. Now, since I have one of my variables, I want to look for an equation with two variables. None of these are going to work. I need to choose one of these two. Okay, up to you, doesn't matter. Maybe I can see this one better, so I'm going to go 5x plus 2 times negative 2 equals 6. So 5x minus 4 equals 6 plus 4. So 5x would equal 10. So that means x is 2. And now that I have two equations, or two of the variables, I'm going to find an equation with 3 and plug them in. So pick one of these up here, one of these original equations, and plug it in. Or you could use this guy right here, because you're looking for y and you have y by itself there. So I could have, I'm going to run out of space here because I messed up, but y equals 3 minus 2 times 2 plus negative 2, because z is negative 2. So this would be 3 minus 4 minus 2. So 3 minus 6, so negative 3. Negative 3. So I'm getting short on time here. I think I'm going to make a second video for these situations. These are the ones where special things happen. So there will be a second video to watch. If you want to try these first on Math Excel, that's great. That might not be a bad idea.